Hello, and welcome to this demonstration of the Segmentation to Trajectories plugin. My name is Sebastian Gilbert, and I will be taking you through the steps of using the Segmentation to Trajectory plugin, then using the output binary image and applying it in the Particle Tracker 2D/3D plugin, and then using the results of the detected trajectories from that in the Chemotaxis tool. First of all, please check out my other video about how to use the neutrophil segmentation plugin. This is because we'll be using the classifier model that we gained from using this plugin and apply it in the next Segmentation to Trajectories plugin. Once you have done that, and have downloaded the Segmentation to Trajectories script and saved in the correct folder in the ImageJ or Fiji directory, go to the Plugins tab and scroll all the way to the bottom until you find the Segmentation to Trajectories plugin. After clicking, this user interface will open. The first input is our video. Select the video that you would like to segment and end up plotting the trajectories of. Here I am using the same example image I used in my first video. Click Open. Then we need to decide the output folder that our binary mask will be saved in. I'm using the same folder that I used in my neutrophil segmentation plugin. Next, we need to choose the classifier model that worked best when segmenting the dark phase neutrophil. When I ran the neutrophil segmentation, I found that classifier model 2 was the best for segmenting the dark phase neutrophil. And like before in our neutrophil segmentation plugin, we have the minimum size of a phase dark neutrophil. This is to discredit any segmented particles that we know are too small to be counted as a phase dark neutrophil. Once completed, click OK. Here we can see that the log window for the trainable Weka segmentation program has opened. And if we refer to the Fiji toolbar, we can see that the log window for the trainable Weka segmentation program has opened. And if we refer to the Fiji toolbar, we can see that the trainable Weka segmentation is using our classifier model to segment the whole video. We can look at the log to see how the trainable Weka segmentation is doing. I've found from previous experience that the classification of a frame takes between 8 to 10 seconds. Here you can see it's taking a bit longer as I have other programs running in the background. Take this into account. When you're selecting the classifier model, make sure that is as best as it can be, as once you've decided which classifier model you want to use, you'll have to be waiting a significant period of time before you can check whether it's really worked on the whole video. I'm going to skip this phase and come back when the trainable Weka segmentation. Welcome back. Once the trainable Weka segmentation program has finished, the following windows will pop up. A probability map of each of the channels of your classifier model, the original video that you segmented, and also this window asking you to click OK to continue. Make sure that you're clicked on the classification result before clicking OK to continue. Once done, some pre-processing will be applied to the probability map. I want to apply the process to the whole video, so click yes. And as before, we have our drawing manager for the regions of interest for all 60 frames now. The first set of numbers relating to the frame, and the other two sets of numbers relating to the coordinates of the region of interest. We also have a results table of the regions of interest for the whole video. But most importantly, we now have a saved copy of the binary image that we have created from the segmentation of our video. Close all background windows so that you only have the binary image of your segmented video. Now this part we're going to manually apply the particle tracker plugin and then apply the Chemotaxis tool plugin. In future versions of our script, I hope to incorporate these stages automatically. If you have not come across the Particle Tracker 2D/3D before, this is part of the Mosaic suite. This is an open source program ready to be downloaded off the internet. If you already have it downloaded onto your Fiji or ImageJ, just search for it in the toolbar. Select, and we are working with 2D data, so press OK. Now, this user interface will pop up. The particle detection relates to the accuracy which we detect the particles in our image. The radius is the number of pixels of the radius of the particles we wish to detect. I have found from experience that 8 is a reasonable number. The cutoff and percentile can be read more thoroughly in the original paper of the Particle Tracker plugin. I'll include the link to the paper in the comments below. I have found from experience that 0.002 and 0.2 have proven to work in the past. If you're not sure about this, just select Preview Detected and a window will pop up with the particles that have been detected in your binary image. If, for example, a particle is long and thin, it may be detected as two separate particles. To change this, increase the pixel radius that you want to be detected. It should incorporate the whole neutrophil. If neutrophil haven't been detected, then maybe the radius that you've selected is too large. So decrease the radius until it is the minimum radius in pixels of the neutrophil you want to detect. I am satisfied with the detection shown here. The last part is the link range. This is the number of frames you would like a particle to be detected if it doesn't come up initially in the segmentation. Decreasing this number will mean particles that disappear and come back will be detected as separate trajectories. However, increasing this number will mean particles that disappear may be then linked to particles that appear that are completely separate to the original particle. I have found in the past that setting this number to 2 is a good compromise between linking particles that disappear but not arbitrarily linking particles that should not be linked. More options are described in the paper and I'll leave a link in the comments below. Once satisfied, click OK. Referring to the Fiji toolbar, we can see that the particles are being detected for each frame, roughly taking about a second. There, it took an extra second to process the detected particles in each frame so that we can now click Visualize all trajectories and the window will pop up visualizing all trajectories. This is really helpful. As you can see, the trajectory is traced along our image. Also, circles have been placed around the particles that have been detected. And if you would like to follow an individual path of a detected particle, double click on the boundary of that detected particle and an extra window will pop up. You can now see the number of the trajectory and also follow its path in each frame of our video. Back on the results window, we can now save all our trajectories into a table. Clicking all trajectories to results will then put all of the data recorded by the particle tracker plugin into a results table with index, trajectory, the frame, and the coordinates and other values. Click File, Save As, and save in the appropriate folder you wish this to be. Now we are done with the particle tracker plugin. Close all windows. And now it's time to use the Chemotaxis tool. This again is ready to be downloaded online for free as an open source software. After editing our results spreadsheet into the following format, we need to save it as a tab delimited text. This is what it will look like. Now, in the Chemotaxis tool, you need to import the data, you need to select the slices that we would like to be included in the data, add dataset, we need to select the dataset, go to plot feature, apply settings, and then the plot graph will become available. Here is our final plot of the trajectories of our dark phase neutrophils. Refer to the Chemotaxis and migration tool, documentation and user manual for further information. Save the plot in the appropriate folder, and you have now finished from segmentation to trajectory.